Welcome to the 1.1 instructional video for Math 20-1. This is where we start to talk about sequences and series. And right away, we're going to talk about specifically in 1.1, something called an arithmetic sequence. Now, a sequence itself is just an ordered list of objects. When we talk about those sequences, we are going to talk about both finite and infinite sequences. The way that we can tell the difference is that finite sequences end, and then infinite sequences will always have these three dots. It's called an ellipsis. And what it indicates is that that particular, I think I spelled ellipsis wrong, but that's okay. It tells us that the sequence goes on forever. Now, you might be thinking, well, here's the three dots right here, but because they're in the middle of the sequence, that's basically just mathematicians being lazy, and they didn't want to actually write out each multiple of 5 all the way to 100. So when we see the three dots at the end of the sequence, it indicates it goes on forever, but when it's in the middle of the sequence, it is going to just indicate that the pattern continues. All right, now when we talk about an arithmetic sequence itself, it's an ordered list of numbers, that's every sequence, but arithmetic sequences are when to move forward in the sequence, we're adding something called a common difference, and to move backwards in the sequence, we're subtracting the common difference. Now, fortunately, there is, they give us the formula, it's right here. It says that the common difference D is equal to Tn minus Tn minus 1. You haven't had to deal with a lot of subscripts yet. What we call Tn is we call it the nth term unless we know what n is. So if I gave you T10, that means that it's the 10th term in that sequence. Now what that allows me to do is if I wanted to find the common difference, what I would do is I would pick a value for n other than 1. And the reason, and maybe I'm jumping around a little bit here, but when we have an arithmetic sequence, the actual term numbers have to be a natural number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's no decimals, there's no negatives. The terms themselves can be negative, but the term number has to be a nice natural number. So if I chose, just as an example, let's say n is equal to 2 here, then I would have term 2 minus term 2 minus 1, which is term 1. But it's not the only one. We could also say that the common difference is, term 3 minus term 2, or I'll write one more here. We could have term 500 minus term 499. Right? Definitely possible to have a sequence that is that long. Now, finding a sequence that long, we don't want to have to write 500 numbers. So instead what we do is we use something called a general term. And the general term is some kind of a formula that would allow us to find any term that we want. Now you have these in your formula sheet, but you have to be able to recognize them and know when to use them. This particular form is one that we're going to use a ton. Arithmetic sequences all follow this form. So I'm just going to write one out really quickly. So let's say I had 3, 7, 11, 15, and then I'll put the three dots to indicate that it goes on forever. Well, for that particular sequence, term 1 would be 3. The common difference, I could figure it out using 7 minus 3, or 11 minus 7, or 15 minus 11, because all three of those are 4. If you do not find that, term 3 minus term 2 or term 2 minus term 1 give you the same thing, then you've either done some subtraction wrong, or it might not be an arithmetic sequence. All right, now term 1 and the common difference is actually all we need, because now I can say that the general term Tn is equal to, I'll write the equation down here just to make sure we see exactly where I'm putting these parameters. I'm going to have that the general term Tn is equal to 3 plus n minus 1 times 4. Now, what is pretty useful to do with these sequences is to simplify that a little bit. This is Tn is equal to 3 plus 4n minus 4, because that 4 distributes into the bracket. And I could write Tn as 4n, 3 minus 4 is negative 1, so 4n minus 1. Now, I do want to show that the point of this, don't get me wrong, we know term 1, term 3, term 4, and term 5, and I hope we can figure out that term 5, actually here, is 19. But what if I wanted to know term 10 or term 100 or term 1,000? Please don't brute force these. Don't actually write out 1,000 numbers. That's crazy. That's way too long. What I'd like to show you is just with a couple of these numbers. Let's say I wanted to find term 4. That's this guy right here. That's term 4. If I use my general term here, that all I'm going to do is, because I'm looking for term 4, I've made n 4. I have to do so on the right-hand side as well. So that means that term 4 is going to be 4 times 4, which is 16 minus 1. I get that term 4 is equal to 15. If you cannot find each and every term given to you using your general term formula, then you've made a mistake somewhere. I'm just going to do one more, and then I'll leave it at that for the instructional video. So if I wanted to find term 2, I would do 4 times 2 minus 1. Term 2, therefore, would be 8 minus 1. and we see that we get 7, just like the sequence that I wrote. All right, that's just the start of chapter 1 here. The instructional video is just meant to give you a little bit of explanation as to where the formula that we're going to use came from.